Hello everyone, welcome back to Hassle Free Labs. This is part 4 of our Ethereum series, and today the training wheels come off. In the first 3 parts, everything lived on your own machine. You ran a blockchain with Ganache, you deployed a smart contract to it, you built a web page that talked to it, and you wired up MetaMask so the user could approve every transaction. But here is the thing, that blockchain only ever existed on your laptop. Nobody else on earth could see it. And the moment you closed Ganache, the entire chain, your contract, every transaction, all of it vanished. It was a private sandbox. A brilliant place to learn, but a sandbox. Today, we step out of the sandbox. We are going to take the exact same counter contract you already wrote and deploy it to a real public Ethereum network, one that runs across thousands of computers around the world, where your contract stays alive whether your laptop is on or off, and where anyone on the planet can look it up and use it. And the best part, the part that makes this safe to practice, it is still completely free. Not a single cent of real money. So let's get started. Before we click anything, let us understand the 3 kinds of Ethereum networks because this trips up a lot of beginners. The first is your local network, that is Ganache. What we have been using. It runs only on your machine, it is instant and it is disposable. The second is Ethereum mainnet, the real one. This is where actual value lives, where a token might be worth thousands of dollars and where every transaction costs real ether, which costs real money. We are not going anywhere near mainnet today. The third kind sits perfectly in between, and it is exactly what we want, a test network or testnet. A testnet is a full public worldwide Ethereum network that behaves identically to mainnet in every technical way, but it runs on free worthless test ether that you can get for nothing. It is the rehearsal stage before the real performance. The most widely used testnet today is called Sepolia, and that is the one we will deploy to. So the mental model for today is simple. We take everything we did on our private Ganache sandbox and we do it again unchanged on Sepolia, a real public network that just happens to use play money. So what actually changes when we move from Ganache to Sepolia? Let us walk through it, because every difference teaches you something about how real Ethereum works. First, the address. On Ganache, your blockchain lived at 127.0.0.1, port 8545, a local address that only your own computer could ever reach. On Sepolia, there is no single machine and no single address. The network is spread across thousands of independent computers called nodes all over the world, and MetaMask already knows how to reach them for you. Second, speed. On Ganache, blocks were mined instantly, you clicked and it was done. On Sepolia, you wait about 12 seconds for each block because thousands of nodes have to agree on it, exactly like real Ethereum. Third, visibility. On Ganache, your transactions only showed up in your own terminal. On Sepolia, every single transaction is public, recorded forever, and viewable by anyone through a website called a block explorer. And fourth, the money. On Ganache, every account magically had 1,000 ether. On Sepolia, no one hands you anything. You have to go and request free test ether from a faucet. Same contract, same MetaMask, same code you already wrote, but a real, shared, permanent network underneath it all. Let us start by pointing MetaMask at Sepolia. The good news is you do not need to add it manually like we did for our Ganache network. Sepolia is built right into MetaMask. Open MetaMask and click the network selector at the very top, the one that currently says Ganache Local. Now, by default, MetaMask hides its test networks to keep things clean for regular users. So if you don't see Sepolia in the list, look for a small toggle labeled Show Test Networks and switch it on. Sepolia will now appear. Click it to select it. And look at the top of your wallet, it now proudly says Sepolia. But notice something else. Your balance shows 0 ether, and that makes perfect sense. This is a completely different network from your Ganache chain. Your account exists here, it is the same address, derived from the same secret recovery phrase, but on this network, it has never received a single thing. It is a fresh, empty account on a brand new network. And before we can deploy anything at all, we need some ether because on a real network, every action that changes the blockchain costs gas, and gas is paid in ether. So where do we get ether on a network that does not just hand it out? The answer is a faucet. A faucet is a free public service that drips small amounts of test ether into your wallet, specifically so that developers like you can experiment without spending anything real. Let us go get some. First, we need your wallet address to give to the faucet. In MetaMask, click on your account name at the top and it copies your full address to the clipboard, the long string starting with 0x. Now, open a new browser tab and go to a Sepolia faucet. There are several good ones. The Google Cloud Web 3 faucet and the Alchemy Sepolia faucet are two popular, reliable choices. Paste your address into the box on the faucets page and click the button, usually something like send me ETH. Now, many faucets will ask you to sign in with a Google account first or complete a quick check. This is completely normal and it exists purely to stop people from draining the faucet with bots. Once you have done that, the faucet broadcasts a transaction sending you the test ether. Give it anywhere from a few seconds to about a minute. Then switch back to MetaMask and there it is. Your balance is no longer zero. You will typically get something like a quarter or half of a test ether. Now that might not sound like much, but deploying our little counter contract costs only a tiny fraction of 1 ether in gas, so this is more than enough. You now hold real, spendable funds on a public blockchain. Now for the main event, deploying to Sepolia, head back to Remix with the exact same counter.sol we wrote all the way back in part 1. Nothing about the contract changes. Compile it if you need to, then open the deploy and run transactions tab, the one with the Ethereum logo. And here is the single most important change in this entire video. Look at the environment drop down at the top. Back in part 1, we selected DevGanache provider to point at our local chain. This time, we select a different option, injected provider MetaMask. That word injected is the key. It means Remix will not talk to any network by itself. Instead, it hands everything over to MetaMask and MetaMask connects to whatever network it is currently on, which for us is now Sepolia. The instant you select it, MetaMask pops up asking permission to connect Remix to your account. Click connect and notice Remix now displays your Sepolia account, your faucet balance and Sepolia's chain ID. Make sure counter is selected in the contract dropdown, take a breath and click deploy. And now, the big moment that never happened on Ganache, MetaMask slides up a confirmation window showing you the gas fee for the deployment priced in real Sepolia test ether. This is you paying to put your contract on a public network. Click confirm. And now we wait. On Ganache, deployment was instant, but that was fake. On a real network, something genuinely different is happening and it is worth understanding. When you click confirm, MetaMask broadcasts your deployment transaction out to the Sepolia network, to those thousands of nodes scattered around the world. Right now, your transaction is sitting in a waiting area called the mempool, along with everyone else's pending transactions. Every 12 seconds or so, one of the network's validators gathers up a batch of these pending transactions, bundles them into a new block, and proposes it to the rest of the network. The other nodes check that block, agree it is valid, and add it to the chain. When your transaction lands in one of those blocks, it is confirmed and your contract officially exists on Sepolia. That roughly 12-second wait you are watching is not lag or a slow computer. It is thousands of independent machines around the world coming to agreement about the state of the blockchain, the very thing that makes Ethereum trustworthy and decentralized. Watch the Remix terminal at the bottom of the screen. And there it is, a green check mark. Your transaction was mined, and your counter contract is now live on a public Ethereum network. Take a second to appreciate that. Now here is where it gets genuinely exciting. On Ganache, your transactions were a private thing visible only in your terminal. On a public network, the opposite is true. Everything is out in the open, permanent and visible to absolutely anyone through a tool called a block explorer. The block explorer for Sepolia lives at sepolia.etherscan.org. And you don't even need to go looking. In the Remix terminal right next to your successful deployment, Remix gives you a direct link. Click it and it takes you straight to your contacts page on Etherscan. Now look at everything that is here. Your contract now has its own permanent page on the public internet. You can see the exact transaction that created it. You can see which block it was mined into and the precise time. You can see the account that deployed it, which is you, your address, and you can see exactly how much gas was paid. Copy your contract's address and you could paste it into that search bar from any computer in the world, and this very same page would come up. Click over to the contract tab and you can even publish and read your counter source code right there in public. This is the real power of a public blockchain. Your contract is no longer a secret on your laptop. It is out in the open, permanent, and anyone, anywhere can inspect it or interact with it. Let us bring it home by pointing our dApp at this new contract and running the whole thing on the real network. Open your index.html from part 3, the MetaMask version. Remember that add-res constant at the very top of the script? Right now, it still points at your old Ganache contract, which does not even exist anymore. So copy your new contract address from Remix or from Etherscan and paste it in, replacing the old one. Save the file and open it in your browser. Make sure MetaMask is still on Sepolia, click Connect Wallet and then click Increment. The MetaMask pop-up looks exactly like it did in part 3, but this time that gas fee is real Sepolia test Ether on a real network. Click Confirm. And now you wait, not the instant snap of Ganache, but the real roughly 12-second heartbeat of a public blockchain, while nodes all over the world process your transaction and seal it into a block. And then the count updates on your page. Now go back to your contacts page on Etherscan and refresh it, and there is your increment transaction sitting in public permanently for anyone on earth to verify. Your web page is now officially talking to a live worldwide blockchain. So let us take a step back and appreciate the whole journey. Across 4 videos, you went from an empty folder to a local blockchain running on your laptop, to a smart contract you wrote and deployed, to a web page connected to it, to a real wallet approving transactions, and finally, today, to that same contract living on a real public Ethereum network, with free test Ether, a public block explorer, and transactions the whole world can see. And here is the beautiful secret to end the series on. Deploying to Ethereum mainnet, the real one, uses the exact same steps you just did on Sepolia. The only difference is that you use real Ether instead of free test Ether. That is genuinely it. You already know how to ship on Ethereum. From a counter that only you could see, to a contract live on a public network that anyone can use, that is a real developer skill, and you built it one video at a time. If this series helped you learn something real, subscribing honestly helps the channel keep making these. Thank you so much for watching Hassle Free Labs, and I will see you in the next one.